The objective of our project is to measure the voltage output of a solar panel at certain angles to determine the incident angle for the highest voltage produced from a light source. The purpose would be to limit the required components of a solar panel array. By reducing components, we can add many benefits to the design, such as reducing the production and maintenance costs. Similarly, this will reduce the risk of failure between each component. This will be accomplished by comparing values of the voltage output from the solar panel to its calibrated optimal value.
So our measurement system uses two main sensors. One is the solar panel itself, measuring the output voltage. The second is the encoders attached to the DC motors to know its angular position. So the solar panel uses electrical energy that it creates by photons exciting electrons to create that voltage. And that voltage can easily be read because it's very consistent in the amount of voltage that's produced based on the amount of light that's hitting the solar panel. So, and to know the angular position of the facing of the solar panel, we use two DC motors, which both have encoders on them. And the encoders shine a light on the shaft where there's a disc that has a set encoded pattern on it. And as it rotates, a certain amount of light is reflected back, and it can measure this and know its exact angle.
Our system would begin at the solar panel, where the light intensity would be converted into a voltage output through the photodiodes on the panel. This measured voltage would be amplified since it would be too small to be measured in its current state. Upon amplification, the data would be fed through the provided DAC and into the software, where operations could be performed on the data. The system would then calibrate the position of maximum voltage output. And after this, two DC motors would be used to adjust the position of maximum angle of incidence.
The application of our apparatus would be most beneficial in the solar power industry. The implementation of this would benefit a solar farm so that it is able to harvest its optimal voltage. Due to the fact that the sun moves throughout the day, the solar panels would have to move accordingly to produce the maximum voltage output. This idea could be implemented in adding solar panels on the top of roofs, similar to what Solar City has proposed. Although, in this case, we would allow the solar panels to reorient itself to capture the optimal sunlight throughout the day. These applications of solar panels allow solar panels to be feasible alternative solar power source.